You can say hi, Kyle.
Hi, Kyle. I miss you, pal.
Hopefully he'll watch it. All right. So we're going to use the disk method to find the volume of the solid of revolution when we revolve f of x around the x-axis between 0 and pi. So this time our function is square root sine x. And the square root of sine x looks something like that between 0 and pi. You could graph it in your calculator and see that. So that's f of x equals root sine x. We're going to rotate that around the x-axis. And I like to make that little arrow because then that reminds me which axis I'm rotating around, because in a minute we're going to rotate around the y-axis. So we're rotating around the x-axis, and in order to find the volume of that solid, we're going to draw a representative rectangle that is perpendicular to the x-axis. And I'm going to super emphasize this idea of perpendicular because we're going to learn another method later on where the rectangle is parallel instead of perpendicular. So here our representative rectangle is perpendicular to our axis of rotation. Okay, so we're going to set this up by our formula. Remember, our formula is volume equals pi times the integral from a to b of f of x, that quantity squared, dx. So in terms of our problem, we have pi times the integral. What are the limits of integration here? 0 to pi. And then we have the square root of sine x. And you'll notice that for a lot of these, they set it up so the integration is not too challenging for you. So when you square the square root, you're just back to sine x. So we have pi times the integral from 0 to pi of sine x dx. And then the integral of sine is negative cosine. So I have negative pi cosine x. And I'm going to evaluate that from 0 to pi. What I would suggest as you evaluate these to make this a little easier for yourself is leave this negative pi, kind of leave that out front, and just evaluate the variable part, because that's, you know, same thing. You can factor out a constant. So I would just leave the negative pi out front, and then we're going to evaluate the cosine of x from 0 to pi. So we have negative pi times cosine pi minus cosine 0. And then when we fill in the values, I have negative pi out front. The cosine of pi is negative 1. Cosine of 0 is positive 1. So we have minus 1. And this kind of illustrates, I think, why I didn't want to get this negative pi involved in there, because there's just so many negatives. It's easy to kind of lose track of all your negatives. So we have negative pi times negative 2. Negative times negative is positive. So that's going to be, that whole volume is exactly 2 pi units. Okay? Whenever you're computing a volume, you should end up with a positive quantity, because volumes are positive. All right, so that's an example where we're rotating around the x-axis and our representative rectangle is perpendicular to the axis of rotation. So let's look at the next example. Okay, in this example, there's a little typo on here. This should say f of y equals y to the 2/3 power. Power. So how are we going to graph that? Yeah, it's y to the 2/3. I said there was a little typo here. I want that to actually be a y. What would it look like if you were finding, and we're actually rotating this. This is the area between 0 and 1, and we're going to rotate that around the y-axis. So how can we figure out that graph? We could plot some points, absolutely. We could plot some points. Let's try that. If we just plot a couple of points, and we know that we're only integrating from 0 to 1, okay? So this time, when I fill out my XY chart, I'm going to choose values for Y and figure out what X is, because remember f of Y is equal to X. So if Y is equal to 0, what's our X going to be? 0. And if Y is equal to 1, what's our X going to be? 1. Okay, so we've got a couple of points. I know I have a point here, and I know I have a point here. Kind of interested to know what it does in between there. Do you know, can you think of something you know the cube root of? That's not a 1, but what would be the next? So we could try 1/8. That would be a point we could pretty easily, oops, I'll put it down here. We could pretty easily evaluate. So if I take the cube root, if I put in 1/8 here, if I take the cube root of 1/8, that's 1/2. And then when I square that, I get 1/4. Okay? So that's another point. So that helps me out a little bit. So when X is 1/4, Y is 1/8, so it's down here somewhere. So it looks like the curve is going to go something like that. Okay, that gives us an idea. All right, so I'm interested in the volume of the solid of revolution generated when we revolve the area bounded by, this is my f of y. X equals 0 is this line right here. And then between y equals 0 and y equals 1. So that area right there is my region. And I'm rotating this time around the y-axis. Okay? So when I rotate around the y-axis, I definitely want my rectangle to be perpendicular to the axis of rotation. So if my axis of rotation is vertical, then my rectangle is horizontal, okay? So I'm going to draw a representative rectangle right here. And that should make sense. If I rotate this rectangle around that y-axis, can you envision the disc shape that you're generating? Yeah, you're generating a whole series of discs. They're stacked up, and we're going to sum them up. So our volume now is, again, our formula is pi times the integral. This time it's going to be f of y squared dy, and we're integrating from some limits of integration. So let's fill it in. So I have pi times, what are my limits of integration along the y-axis? 0 to 1, okay? My f of y is y to the 2/3 power. That's f of y. So I have y to the 2/3 power. I have to square that. And I'm integrating with respect to y. So first do the squaring and then do the integration. So pi times 0, the integral of 0 to 1. When I square the 2/3, remember a power to a power, you're multiplying. So that should be y to the 4/3 power. dy. And now to kind of finish this up, we can go ahead and integrate. So when I integrate y to the 4/3, I want to add 1, so add 3/3. So I have y to the 7/3. And then I'm going to divide by 7/3, so multiply by 3/7. And then I just have to evaluate from 0 to 1. So we get pi times, I'm going to pull the 3/7 out front. And then I just have 1 to the 7/3 power minus 0 to the 7/3 power. That's 1 minus 0. So we just get 3 pi over 7 as our solution. Okay? So you're going to follow this basic formula every time. You're going to follow the same formula. You're going to create your graph. You're going to look for your limits of integration. Please draw a picture so you can see what you're doing, and be sure you draw your representative rectangle. It may not seem like completely necessary right now, but as we add several more methods of integration as we go, you're going to appreciate why you need that rectangle. Okay? So I'm going to give you the rest of the period today to get started on your homework and think about being prepared for a homework quiz for tomorrow. Okay?